Here is something your science teacher got wrong. Mercury, the planet closest to the Sun, is supposed to be simple. A dead, scorched, airless rock. The solar system's least interesting world. A place so hostile and so barren that for most of human history, we barely bothered looking at it. That is what we assumed. And almost every single part of that assumption turned out to be wrong. Mercury has a magnetic field it shouldn't have. Ice it shouldn't be able to keep. A core so massive it defies everything we thought we understood about how planets form. Geological features we have never seen anywhere else in the solar system and cannot explain. And here is the detail that should genuinely unsettle you. Whatever happened to Mercury, the slow cooking, the shrinking, the transformation from a potentially Earth-like world into what it is today, is going to happen to Earth too. Mercury is not just a planet. It is a preview. For a planet this close to us, Mercury has managed to keep its secrets remarkably well. The problem is not distance. Most of the time, Mercury is actually Earth's closest neighbor, closer than Venus, closer than Mars. In pure distance terms, reaching it should be straightforward. The problem is the Sun. When you try to observe Mercury from Earth, you are always looking directly toward the most blinding object in our sky. Mercury hugs the Sun so tightly, completing a full orbit every 88 days, that from our perspective it almost never moves far enough away from the Sun's glare to observe properly. Like trying to study a candle flame sitting 1 inch in front of a searchlight. And getting a spacecraft there is even harder than it looks. Mercury moves faster than any other planet, named after the fastest Roman god for exactly this reason. A spacecraft launched from Earth carries enormous speed, but Mercury is falling deeper into the Sun's gravity well, which means to match its orbit you don't just need to speed up, you need to slow down dramatically against the Sun's pull, which requires staggering amounts of fuel. Get the approach wrong by even a fraction and you don't land near Mercury. You fall into the Sun. This is why, despite being our neighbor, Mercury remained one of the least understood planets in the solar system for most of human history. And when we finally did get a spacecraft there, what it found turned everything upside down. In 1973, NASA launched Mariner 10, the first spacecraft ever sent to Mercury. Getting there required an entirely new technique. Engineers used Venus's gravity as a slingshot, flying past Venus first and letting the planet's gravitational pull redirect the spacecraft down toward Mercury. It was the first time any mission had ever used a gravity assist maneuver, and it worked. Mariner 10 flew past Mercury 3 separate times. What it saw was not what anyone expected. At first, Mercury looked familiar. Gray, cratered, battered, similar in appearance to our moon. One structure stood out immediately, the Caloris Basin, an impact crater wider than the state of Texas, carved by a collision so violent it sent shockwaves through the entire planet and deformed the surface on the exact opposite side. But then the surprises started arriving. Mercury has towering cliffs, some nearly 3 kilometers high, stretching hundreds of kilometers across the surface. Nothing like this exists on the moon. These were a clue that nobody fully understood yet. And then the finding that genuinely shocked scientists. Mercury has a magnetic field. Before Mariner 10, nobody expected this. A magnetic field requires an active, churning liquid metal core, the same engine that protects Earth from the Sun's radiation. Mars doesn't have one. Venus doesn't have one. A planet as small as Mercury, this close to the Sun, this old, it should have cooled and died billions of years ago. And yet, the field was there. Weak, about 1% the strength of Earth's, but unmistakably present. Which meant something was still alive inside Mercury. Something that had no business still being alive. But Mariner 10 could only image 45% of the planet's surface, always approaching under similar lighting conditions, always missing the poles. More than half of Mercury remained completely unseen, and the poles, scientists suspected, were hiding something extraordinary. It took 23 years before humanity got another look. In 2004, NASA launched Messenger, a spacecraft designed to do what Mariner couldn't. Not just fly past Mercury, but enter its orbit, map every centimeter of its surface, peer into its interior, and finally, look directly at those poles. The journey took nearly 7 years. To bleed off enough speed to match Mercury's orbit without falling into the Sun, Messenger had to loop around Earth once, Venus twice, and Mercury itself 3 times, gradually slowing down with each pass before finally sliding into orbit in 2011. What followed was 4 years of revelations. First, the volcanoes. Mercury's surface is covered in vast, smooth plains of ancient, solidified lava. This planet was once volcanically ferocious, alive in a way nobody had predicted for something this small and this close to the sun. Second, the shrinking. Those towering cliffs Mariner 10 had spotted? Messenger revealed they were everywhere, wrapping around the planet like wrinkles on a drying apple. Mercury has been shrinking. As its interior cooled over billions of years, the planet physically contracted by an estimated 14 kilometers in diameter, 5 times faster than any model had predicted. The cliffs are the scars of that contraction, the crust buckling and folding as the world underneath pulled inward. Third, the core. Using precise measurements of Mercury's gravity, shape, and rotation, Messenger determined that Mercury's core, the dense iron ball at its center, makes up 57% of the planet's total volume. Earth's core, by comparison, is only 17%. Mercury is essentially a giant iron ball wrapped in a thin skin of rock. And unlike what we expected, that core is not entirely solid. There is a liquid outer layer, still churning, which explains the magnetic field that should not exist. But the magnetic field itself held another secret. It is not centered inside the planet the way Earth's is. It is shifted, offset toward the North Pole, tilted and asymmetric in a way that our current understanding of planetary physics cannot fully explain. And because Mercury sits so close to the Sun, solar winds constantly batter and twist that field, stretching it in ways that have no parallel anywhere else in the solar system. Mercury's interior is stranger than we imagined, and its surface, stranger still. For years, radar signals bounced off Mercury from Earth had been returning something unexpected. A bright reflective signature coming from the poles. Something was there, something that reflected radar in a way consistent with only one substance. Water ice. On the planet closest to the Sun, in a place where surface temperatures reach 427 degrees Celsius. Ice. Messenger confirmed it. Enormous deposits of frozen water, locked inside craters at Mercury's north and south poles. The explanation, once you understand it, is almost elegant. Mercury spins perfectly upright, unlike Earth, which is tilted 23 degrees on its axis, giving us seasons, giving the poles long periods of sunlight. Mercury stands completely straight. The sun never rises high over its poles. It only ever strikes them at an extreme sideways angle, which means the floors of deep craters at Mercury's poles have never seen direct sunlight. Not once. In 4.6 billion years. These craters sit in permanent shadow, and in that permanent shadow, temperatures drop to minus 180 degrees Celsius. Cold enough to preserve ice delivered by ancient comets and asteroids, sitting undisturbed for billions of years. Frozen water, sitting in permanent shadow, on the planet closest to the Sun. If Mercury can surprise us this completely, what else have we gotten wrong? Messenger answered enormous questions, and in doing so, opened new ones that are arguably more unsettling. Scattered across Mercury's surface are features unlike anything seen anywhere else in the solar system. Shallow, irregular depressions with bright halos, scientists call them hollows. They appear to be actively forming right now. Fresh, young by geological standards. The leading theory is that they form through sublimation, volatile materials in the rock evaporating directly into space under the sun's radiation, leaving behind these strange collapsed pits. If true, Mercury's surface is still actively changing, still losing material, still transforming. But here is the deeper implication. The presence of volatile materials, substances that evaporate under heat, suggests Mercury may have started its life much further from the sun than it sits today. A planet that formed at its current location, bombarded by the sun's radiation for 4.6 billion years, should have had those materials stripped away long ago. Instead, they are still there, just below the surface. Something moved Mercury. Some series of gravitational interactions in the early solar system pushed it inward, from a more moderate orbit closer to where Earth sits today, down into the brutal heat of its current position. Which raises a question that is no longer entirely abstract. Mercury is not just a planet. It is a timeline. As the sun ages over the next billion years, it will expand, slowly at first, then dramatically. Mercury will be swallowed entirely. Then Venus and Earth, the new innermost planet, will experience exactly what Mercury is experiencing now. Scorching temperatures, atmosphere stripped away, surface baking under radiation. We will look like Mercury. We are looking at our own future and calling it the solar system's least interesting world. But before that future arrives, and it is billions of years away, so breathe. We are sending one more mission. In 2018, Europe and Japan launched Bepi-Colombo, named after the engineer who designed Mariner 10's flight path. After years of gravity assists, it is now on final approach and will enter Mercury's orbit in November 2026. Bepi-Colombo will carry instruments more sensitive than anything Messenger had. It will study those hollows, map the magnetic field asymmetry, search for answers to questions we haven't even fully formed yet. And one of its first tasks will be to find the crater Messenger made, because NASA deliberately crashed the probe into Mercury's surface at mission's end, creating a fresh impact site in a known location. Bepi-Colombo will photograph that crater and measure how much it has changed, using our own spacecraft's grave as a scientific instrument. That is the kind of world Mercury is, the kind of place where even death becomes data. We spent most of human history dismissing Mercury as a dead, overcooked rock, and it turned out to have a living core, polar ice, a magnetic field, shrinking cliffs, unexplained surface features, and a history that may mirror our own future. The planet that was supposed to be the simplest thing in the solar system turned out to be one of the most complicated. And Bepi-Colombo hasn't even arrived yet. Whatever it finds, whatever Mercury is still hiding, we will know by the end of 2026. The question is whether we are ready for another surprise.